Alright, book problems from chapter 1 and 2. First one, significant figures. Remember the rules, the zeros in front, we never count. Zeros on the right side, we count when there's a decimal point. Otherwise, you're counting all of the digits. On the powers of 10, we're only looking at the front number called the mantissa. We're ignoring the power of 10. Next one, they're giving some measurements here. The length of the room is 16.40 meters. The width is 4.5 meters, and the height is 3.26 meters. When you're doing a word problem, you should be copying down all the measurements and labeling the appropriate variables on them. We're also going to label the variable of what we're looking for. This time we're looking for volume. The reason we do this, there's two reasons. One, we want to make sure that the unit labels all match each other. If they don't match, we'll be doing a unit conversion here. Second, we need to figure out which formula we're going to use, and we need the V formula that has these three letters in it. So we're looking for the formula with all those letters in it. Volume, length times width times height. In the formula problems, you have to show which formula you're using first, and then when we substitute the numbers into the formulas, you also include the unit labels. So when we multiply, not only do we get an answer on the calculator, but we're showing that meter times meter times meter makes cubic meters. Alright, last step, we're going to round for significant figures. This number has 4 places, this one has 2, and this one has 3 places. The rule is you're going to round to the smallest number of significant figures. We're going to round this one to 2 places. So 2 places, we'll draw a line here. 0 is less than half, so this number is going to round down to 240 cubic meters. Alright, looking at the graph. What is the mass of 30 cubic centimeters of each substance? So we have to read all 3 numbers at 30 cubic centimeters. So we're going to do some interpolation here. I'm going to go up to graph A, up to graph B, up to graph C. For A, we're in between 0 and 100. It looks like it's about 80, and we have to remember the unit labels, 80 grams. This one's right in the middle, so in between 200 and 300 would be 250 grams. And the last one's right on the line, 400 grams. Last, we have to round for our significant figures. All of these numbers and all of these numbers are measured to 1 significant digit, so we're going to have to round all of these. That 250 needs to go to 1 place. And this is one of those trick ones. It's 250 is in the middle of 200 and 300, so you have to round to the even number. 200 is even, 300 is odd. Alright, let's say we have 100 grams of each substance. Let's find the volume. So this time we're going to start on the y-axis at 100, and we're going to read all 3 numbers. Again, this is interpolating because we're inside the graph. But down here, letter A is over on the right this time, so it's a little bit more than halfway, so I'm going to say 36, maybe 37 cubic centimeters. This one's close to 10, so I'll call it 12. This one's close to 10, I'll call it 8. And then again, these are all 1 significant digit, so I'm going to have to round the 36 up to 40 and around the 12 down to 10. In one sentence or two, describe the meaning of the slopes. In our notes this week, we said that the slope is the velocity? No, that's only true for a position time graph or a distance time graph. This is a mass versus velocity graph. If we look at the slope, slope is change in y-axis over change in x-axis. So our equation would be the slope is the change in mass over change in volume. Mass over volume is a formula you should recognize from middle school or from chemistry. That is the definition of density. So this graph is showing the density of 3 different materials. Our unit labels, rise over run, we're going to have grams over cubic centimeters, and if you remember from a chemistry class, that is the units for density in chemistry. In physics, we use kilograms and liters. Alright, what does the y-intercept tell us? Down here, all 3 of the graphs go to 0. That intercept is telling us that if the independent variable is 0, then the dependent variable has to be 0. So if our volume is 0, the mass has to be 0. All right, reading our graph here, the graph describes the motion of a cruise ship during its voyage through calm waters. The positive d direction is defined as south. So I labeled south up here on the positive side of the graph, and the negative side of the graph then would be north. They're asking us what is the ship's average speed and what is the average velocity. On the graph, the slope of the graph tells us the speed and the velocity. For the speed, we want the absolute value of the slope. That would be the slope without any direction on it. And the velocity would be the slope with the direction sign on it. So for a slope, we have to choose 2 points on the line. And it's going to be the change in the y-axis over change in x-axis. So we have change in position over change in time. So choose my 2 dots. If you can choose 0, 0, always do it, because that makes your equation a lot easier to work with. And then the other one will be this point. So for my rise, actually it's a drop. We're going down 1 meter. And then for my run, we're going over 3. So minus 1 meter over 3 seconds comes out to 0.3333 in the negative direction. And then rounding for significant figures, all of our numbers are measured to one place. I'm going to have to round this one to one place. So we'll get negative 0.3 meters per second. So for my speed, we're going to take the slope without the plus or minus sign. For the velocity, we're going to use that minus sign to tell me that the direction is north. All right, next graph. Again, we're looking for speed and velocity, so we'll use the same slope formula. It's change in y-axis over change in x-axis. And we'll choose 2 points on the line. Again, you want to choose 0. So this one, my rise will be 10 and my run will be 15. And make sure you're including the unit labels. The rise is kilometers and the run is in meters. So when we divide it, we'll have our units of kilometers per minute. All right, rounding, this number has 2 significant digits, but this one only has 1. And the rule is you're going to round to the number that has the least number of significant digits. So we're going to round to one place on this one. 6 is more than half, rounds this 6 up to a 7, so 0.7. And units are kilometers over minutes. So for our speed, we have 0.7 kilometers per minute. The velocity, we have the same number, but we have to include the direction. Now notice on this one, it didn't tell us the direction. If they don't tell you your direction, then we're going to say it's going forwards. What does the slope of a position time graph tell us? It tells us the velocity. All right, new graph. Describe the position of runner A relative to runner B at the y-intercept. So right along here, we can see runner B is at 0, but runner A is 1, 2, 3, 4 meters in front of him. So what that means on your race, this guy has a head start. Runner A is 4 meters in front of runner B. Question B, which runner is faster? Notice that these have 2 different slopes, and we know the slope tells our speed or our velocity. So the steeper the slope, the faster the person's running. So B has a steeper slope, so he's running faster. A has a flatter slope, so he's running slower. Last question, what occurs at point P? Right at point P is, you can see they're in the same position at the same time. And then after that, now runner B has a farther position than runner A. So this is the point where runner B is passing runner A. So on my animation down here, the 2 guys run right here when they're at the same point at the same time. That's point P. And then after that, runner B is in front of runner A. All right, looking at a graph here, this is position time graph. The slope of each one of these lines will tell me the velocity of the cows. So they want us to put them in order from slowest to fastest. So the slowest is going to be the flattest slope, and the fastest will be the steepest. So the flattest one looks like Moolinda, then the next one would be Dolly, then the next one would be Bessie, and Elsie is going the fastest. A bike travels at a constant speed 4 meters per second for 5 seconds. How far does it go? So when we're reading the problem, we want to write down each measurement and label the variable that goes with it. Meters per second, I recognize that as speed or velocity. And since it actually tells us the speed, doesn't it? 5 seconds would be our time. So t is the symbol we use for time. And how far does it go? We're trying to find the distance. Again, we want to write the numbers going downwards like this because we want to check and make sure the unit labels match each other. Seconds and seconds are good. If one of these is minutes or meters per minute, we're going to have to do a unit conversion so they match each other. Second, we want to find the formula that has d, t, and v in it. That would be our distance formula is velocity times time. Substituting, we put numbers and unit labels into the formula. So when we multiply, we're going to get 20. When we multiply our units, seconds and seconds are going to cancel each other out, and that way we're showing where the meters on the answer comes from. So we've got 20 meters. Last step, we have to check for significant figures. This measurement has 2 places, this one has 2 places, but our answer only has 1. So if these are both 2, then we have to have 2 on the answer. The way we do that is just putting a decimal point at the end. When there's a decimal point, the 0 counts. So 2 and 0 gives us 2 significant figures. End of problems.